How do you debug Java applications with threads? Have you ever wondered how to tackle the challenges of debugging Java applications that use threads? It can be tricky, but with the right approach, you can effectively identify and fix issues. Let's break it down step by step. First, it is essential to understand how threads operate. Threads run concurrently, which means they can cause problems like synchronization issues, deadlocks, and race conditions. Deadlocks happen when two or more threads wait indefinitely for resources held by each other. Race conditions occur when the timing of thread execution leads to inconsistent results. Recognizing these issues is the first step in effective debugging. Next, using an integrated development environment, or IDE, that supports thread debugging is a game changer. Modern IDEs like IntelliJ IDEA, Eclipse, and JetBrains Writer come with built-in tools for this purpose. In the debugger window, you can view all active threads, their call stacks, and their current states. You can even pause, resume, or terminate individual threads to isolate any problematic behavior. Setting breakpoints that trigger only on specific threads can help you focus on the issues at hand. Controlling the execution flow of threads is another useful technique. You can freeze or suspend individual threads to control the order in which they execute. This is particularly helpful for investigating deadlocks or timing-related bugs. By preventing some threads from running while observing others, you can reproduce and analyze concurrency problems more reliably. Employing exception and conditional breakpoints can also streamline your debugging process. Exception breakpoints will halt execution when a specific exception is thrown, which is useful for catching errors related to thread operations. Conditional breakpoints stop the program only when certain conditions are met, such as a specific thread identifier or variable state. This reduces noise during debugging and helps you focus on what matters. Analyzing thread dumps and logs is another effective strategy. Tools like JStack can capture thread dumps that show the state and stack trace of all threads at a specific moment. By analyzing these dumps, you can identify deadlocks and thread blocking. Additionally, logging thread activity with timestamps and thread identifiers helps track interactions and timing issues. Detecting and debugging deadlocks and race conditions can be challenging. Deadlocks can be identified by checking which threads hold which locks and which are waiting. Race conditions may require more careful observation. Using logging or trace points that do not suspend threads can help you see how threads interact without disrupting their timing. Adding logging at method entry or resource acquisition points can also help pinpoint problematic sequences. If your IDE supports hot code replace, or HCR, you can modify code during a debugging session without needing to restart the application. This feature allows for quick fixes and testing of thread-related code changes in long-running applications. Finally, adopting thread-friendly design practices can prevent many issues before they arise. Writing thread-safe code with proper synchronization, avoiding shared mutable state, and using concurrent utilities can significantly reduce bugs. Understanding how your code manages thread interactions simplifies the debugging process. By combining these techniques, leveraging IDE features, controlling thread execution, using targeted breakpoints, analyzing thread dumps, and applying careful logging, you can systematically identify and fix threading bugs in Java applications. This structured approach will make your debugging efforts more effective and efficient.